Okay, so let's talk a little bit about the color of soil and the importance of being able to identify your soil color, and more importantly, how to be very precise with your interpretation of soil color. So we are going to look at the classic Munsel soil color charts. So here we go with soil color. And soil color is obvious to most of us. When we look at soil, we can see, for instance, in the image here, that there are many different colors. It's not all just the same color of brown. So how do we talk about this and describe it so that we can understand what is causing these color variations, and so that we can try to put them in order and classify our different soil types? The soil color plays a large role in classifying soil into different categories. And just like with plants and plant species and all living things, they're given a taxonomy. There is a separate taxonomy for soils. It's not as complicated as the kingdom, phylum, and all the way through to the genus and species. This is a little bit more simple, but every soil is put into a category of soil taxonomy. And the color is one of the primary indicators for what type of soil it is. And different types of soil have different characteristics. So in the United States, there are many different types as indicated here on this USDA diagram, and it's calling out the names of some of these soils. We'll talk in a little bit greater detail about these in the coming weeks, but you can see there's mollisols, iridosols, entosols, and each of those have different colors and different brightness categories. So one reason that we want to know the color is so we can help to classify and describe the soil. Additionally, the color of the soil can be an indicator to different types of minerals that may be present and therefore available to your plants. And finally, there are some environmental factors that can affect the color of your soil. And so you need to recognize those and be able to look out for them, because those could be hazardous conditions for your plants. And then, of course, the color of soil has been important to humanity for a long time, longer than history. And you can see in uh, ancient artwork and pottery and building materials and paints and everything else that the vast array of colors in the soil, which were used as materials for these uh, important human cultural artifacts, were very relevant. And they're just as relevant to us today, although many of us may not think about the color of soil too often. So as soils are being explored and classified, usually there's a profile that is dug, and we want to examine that profile at the various depths to identify the horizons and their thickness. But in particular, we're looking at the color of the horizons for this topic. And where those colors start and where they stop can tell us many different things. And so the development and the distribution of the color, therefore, is a part of the process of weathering. And we can use that to help us understand the rate of weathering in this particular area. And then additionally, organic matter decomposes into a black material that we call humus. And so how rich the soil is in humus will be indicated by how dark brown or black the soil is. And then where that is in the soil profile can be an indicator of how deep the humic acids have penetrated into the soil, and therefore how deep the root system and the the topsoil, the growing depth for your plants is. And then finally, environmental factors such as water logging or going anaerobic can be seen as a visual representation. If you ever have saturation and no oxygen in your soil, you will see evidence of that in the color. So some of the colors that you can see in soil, first of all, is like a white color, typically. Some people describe it as a clear color, but for me, it's easier to describe it and think about it as white. And mainly this is influenced by certain materials found in the soil, such as calcium carbonate, gypsum, and other salts. Many of these were deposited as marine sediments, so in places that were previously underwater. And Chula Vista has these white soils, these calcium carbonate based soils. And so the image there, you can see on the left-hand side of the soil profile, that white, chalky, kind of yellow, creamy color is influenced by the mineral component of what it's made up of. And many times it's an ancient ocean sediment. You can also end up with a layer of white soil if pigments have been removed, and that can happen as a chemical process. Oftentimes when organic matter hits the soil, the acids in the organic matter, the humic acids that are emitted and released by the living things, what they're doing is they're actually helping to mineralize the soil. They are taking the minerals locked in the soil particles, and they are, with enzymes and catalysts, they are dissolving them from the rock and putting them into their bodies. And then that gets taken up by the plants when the bodies die. But at that layer where the organic matter meets the bedrock or the subsoil without living things, you can find sometimes a white layer. And this is where they kind of call it clear, because it's been leached of its minerals. And so if you see either of these, it's an indicator of what's going on. Now, on the brown side, brown soil color is what we typically think of, and that's often created by the good stuff, which is the organic matter. And the humic acid, usually darkest at the very top, and then as it goes down, there's a gradient, and it gets lighter and lighter as you go. So the darker the color usually indicates the higher amount of decomposed organic matter, and we typically refer to that as just humus. So the humus is dark, and the more humus, the darker the soil. Where do you find the most humus? In the O horizon and in the A horizon for topsoil. The other thing that you can see is how deep the dark material goes. And oftentimes, right at the base of where you see your dark brown soil, you'll see a pretty stark line that transitions to like a red or yellow color. And that indicates that that's as far down as the organic matter influences, and anything below that is influenced primarily by the mineral content, not necessarily by the organic matter content. You can still have life below that boundary line, but it'll be a different kind of life that has different characteristics and qualities. Now, yellow and red are both typically caused by iron, and iron can exist in different forms, and whether it's one form or the other, you'll get a red color or a yellow color. But if you see reddish in your soil or a yellowish in your soil, typically that is caused by the iron content of the soil. And when iron is exposed to oxygen, you get iron oxide, which is rust. So that rust color that you see on rusty metal is literally the same material that is present in the red and yellow soils. It's quite literally rust in the soil. It's iron that is present in your soil and with oxygen has oxidized, and based on the form that the iron takes in its parent material, it'll either uh, give off a yellow color or a red color. In our mountains, there are patches that you can, as you drive through to Julian or so, you can drive through patches where you see quite distinct red color, and then other areas where there's yellow. And it's pretty interesting to note the difference in the color of the soil. And the last one here is gray, and it can be kind of a whitish color. Usually this is found in water-logged soils. So in the soil where you don't have a lot of oxygen, oftentimes in clay, and in areas that are either irrigated and overwatered, or areas that are naturally depressions that become little wetlands or bogs in nature. If you dig down into that soggy, saturated soil, oftentimes you'll find gray or white colors, and that's because of the lack of oxygen, which is causing a change in the microorganism. So microorganisms, some of them need oxygen and some of them are fine without oxygen. And as you have different microorganisms in different places, and these waterlogged soils usually have quite a buildup of organic matter. So the microbes, they go to town, they start decomposing the dead roots and all the different things that fall in the soil. And without oxygen, you have these patches of where decomposition is taking place and where it's unable to take place. You end up with kind of a mottled pattern, kind of like a marbly pattern. And the image here shows it right where it transitions from that yellowish color down to the subsoil, which looks to be like a clay type of texture. You can see some white and gray mottling in there, and that is the indicator of a waterlogged soil. Your plant roots do not typically like this type of soil, and even in the trench, you can see that there's that might even be groundwater that they've hit, or either that or just rainwater falling in. So that's a soggy soil. So how do we talk about this in a systematic way? Because that's what science is all about. It's about making sure that when I say something, that you can copy it and that you can understand it and interpret it to be very exact and precise. So the USDA, they needed a system for how to classify soil by color. So they went out and they got in touch with a professor, an art professor, and his name was Munsel, Albert H. Munsel, and he was a teacher, an art teacher, and he had developed a system for describing color. And the USDA chose to adopt the Munsel system as its official methodology for classifying soil color. And this system is used for all over the world to classify soils into different categories. And we can find similar soils in different parts of the world, but in similar climates. And so we can start to understand patterns of how the soil interacts with the climate of a specific region. And it can give you a lot of clues on how to properly manage and take care of that soil so that it is not lost for future generations. So the basis for the Munsel system are three distinct categories or three distinct characteristics of color. So when you look at color, most of us just think of our primary colors or kind of a different range between them. But there's three main values, there's three main characteristics of color. And those are the hue, the value, and the chroma. In different disciplines, they will use different names, different terminology for these 3 different classifications. But for soil science, they use hue, value, and chroma. And this gets into a little bit of color theory if you've taken any art classes or even our floral design classes. So the first category, hue, this is what you typically think of as our different colors. The primary colors and the secondary colors, this is the hue. And so Munsel described 5 principal hues: red, yellow, green, blue, and purple. And then within that, there were 5 intermediate hues. So for example, you could get a yellow and a red. And if you look on the wheel on the right-hand side, what's between yellow and red? Well, of course, it's orange. So it kind of gets back to your preschool days where you paint and you learn how to mix colors. So when we separate those out and call them different names, what we're talking about are the different hues of color. So for soil, our first job is to try to recognize what hue are we working with. And then next there's the value, which is also referred to as just plain lightness. How light or how dark is each specific hue? So these all work together. It is describing the overall intensity or how light or dark a color is. So in the diagram you can see below, you can see we have different hues arranged vertically. And number 1 is a very light value, and number 10 would be a very dark value. So it goes from almost white to almost black, and in between you can get lighter or you can get darker. So this is where you have a light green or a dark blue, for instance. This is based on the color value. And then finally we have the chroma, which could also be described as the saturation of color. And you can think of it as the strength or how dominant is the hue in that color. So on the spectrum of light and dark, how much does the hue shine through? It's a little tricky to describe, and you can't really think of chroma by itself. You wouldn't necessarily say, oh, we've got strong blue or weak blue, the same way you could say you have a light blue or a dark blue. But you have to compare it to the entire spectrum. So in the image on the right-hand side, you can see we look at a table that shows a higher chroma and a higher value or lower value. So as you go higher in chroma, it becomes more bright red, you could say. And as you go up in value, the brightness gets more bright. As you go down in value, that brightness, saturation, or the strength of that red color is diminished a bit. And so when you consider both value and chroma together, you get a very nice palette that you can use to try to place you somewhere on a very precise location. So here's what a Munsel chart looks like. You can see first we look at the hue. So this whole page is for the hue, which is described as 10YR, which the common name, they call it orange yellow. So all of these different chips of color are orange yellow, but let's describe that in further detail. Notice the value or the lightness on the left-hand side. And as you go up in lightness, you can see going up to 9, it gets almost white in color. And going down to 2, it gets almost black in color. But then we look at the chroma to help us move horizontally on the chart. For instance, in this example, there's a yellow type of a paint, and you want to find which one it is. You see, okay, it looks like that one there. Well, how do you describe that? you would say it is value 5, chroma 6, because you can see the chroma numbers down on the bottom. And so you use all of these uh, classifications to get you into a very specific color. And we can use these colors to act as a clue that lets us know what's going on with the mineral content of a soil. And the greatest influence of soil color as far as minerals are concerned is iron. We talked about organic matter, we talked about oxygen or anaerobic soils, but iron by far plays the greatest impact on the color of the parent material. And iron can exist in many forms. So this table here down below is showing common pigmenting agents in the soil. And you can see they range from reddish to yellows to grays and white and even dark, almost black with the instance of humus. But notice above the names of each mineral, we have the code, the color code. And this is according to the Munsel chart. So we have our hue, our value, and then the slash, and then the chroma with each of our different chips that are representing the colors of different minerals. So when you practice with some Munsel charts, it's important to try to have a bit of a systematic technique. And there's a bit of subjectivity involved. But ultimately, if you can be as precise as possible, it can open a door to help show you what is the parent material made of, and therefore what kinds of tendencies you'll have if you're trying to grow plants in a soil.